Hi class, today we are going to continue with solving systems, and we're going to look at our third method of solving a system, this time using a strategy called elimination. These are just reminders that you don't need to put down in writing because we've already done this. Okay, but just a reminder that two or more linear equations together form a system of linear equations, and that an ordered pair that makes both equations true is a solution of the equations. Also want to remind you that some systems have no solution, and that some systems have an infinite number of solutions. Okay, another walk down memory lane. The first method that we used to solve a system was by graphing. Okay, when we were able to find just one solution, that meant that our lines intersected and we were able to write an ordered pair. But we also recognize that sometimes when we graph a system, the lines are parallel and there are no solutions. And other times, one line would graph upon the first line and they would overlap, they would be the very same line, and that there were an infinite number of solutions. That was our first method for solving a system, graphing. The second method was completely algebraic. Okay, and that's what we have been working on the last few days, which is the substitution method. With the substitution method, we would need to find one variable in the system and recognize that it was equivalent to another expression, or we would have to rewrite the equation, okay, and solve it for one variable so that it was equal to an expression, and then we would substitute that expression into the other equation. So today we are going to look at and learn the third method of solving systems. It's called the elimination method. I really like the name of this because I think it's very telling. It describes what's going to be happening. But when I was growing up and learning algebra, this method was called linear combination. So if you ever see that linear combinations, or if I accidentally say it, recognize that it's the same as elimination. What's extremely important with the elimination method is that the equations must be in standard form. The reason why is that the variables must line up because we work with both equations simultaneously. We work with the equations at the same time. Number puzzles lend themselves really well to the elimination method. Take just a minute and write down this number puzzle. What we know is that the sum of two numbers is 28, the difference of two numbers is 6, and what are the two numbers? Well, this is definitely a problem where, you could sit and spend a few minutes and think about numbers that add to 28 and subtract to be 6. But imagine if those numbers were extremely large. Then an algebraic method, okay, would be better than a guess and check method. So our steps for using the elimination method, okay, write an equation for each statement, decide which variable to eliminate, add the two equations together and solve, and then finally go back to the original system and solve for the other variable. It doesn't have much meaning to you now because you haven't gone through any examples, but this will continue with this process. Okay, so write an equation for each statement as the first step. Well, first thing I need to do is define what my variables are. I'm going to let x represent the first number, and I'm going to let y represent the second number. And yes, okay, if you didn't know, that's not just a hashtag symbol, that's also a number symbol. Okay, so the sum of two numbers is 28. I know that sum means addition, so I know that my first equation is going to be x plus y equals 28 because the two numbers add up to 28. I also know that the difference of the two numbers is 6, so x minus y equals 6. Step 2, sometimes it requires a lot of work, sometimes it requires no work. And since this is the very first problem that we're starting with, okay, of course I'm going to start with one that requires no work. Because if we add the two equations, as is. We add the two equations. X plus x is 2x. Y plus negative y is 0. The y values are eliminated because their coefficients are opposites, positive 1 and negative 1. 28 plus 6 is 34. So when I solve this equation, I know that x is equal to 17. So I have half of my solution. Now I just need to go ahead and solve for the second variable, or y. So I'm going to go ahead and use I need to go back to the original system, and it doesn't matter which of the equations I use. I'm going to go ahead and use x plus y equals 28. Okay, so I'm going to substitute 17 in for y. X plus 17 equals 28. So when I solve, I will need to subtract 17 from each side. And that leaves me with x equals 28 minus 17 is 11. Except it was x that was equal to 17, not y. Okay, Mrs. Caldwell just made a mistake. You've seen that happen before. Okay, so the equation is x plus y equals 28. X is 17, y is not 17. So I'm going to replace x with 17. Sorry about that, hope you weren't using pen. If not, just scratch it out. Now when we solve, y is equal to 28 minus 17, or 11. So our last step is going to be to write the solution. And our solution is 17, 11. Okay, it would be a great idea to check. Well, remember, the original problem said that the sum of the two numbers was 28. 17 plus 11 is 28. And that the difference of the two numbers is 6. 17 minus 11 is 6. Sure enough, we have the correct system, the correct solution to our system. Now, not every problem that you're going to be working with comes from a number puzzle. So this is what a typical elimination problem will look like, or a typical system will look like. With substitution, it was really important, okay, to make sure that we did have our two equations side by side, because we worked with them at different times. But for elimination, we need to have our equations written one right above the other. 5x minus 6y equals negative 32. And 3x plus 6y equals positive 48. Okay, now as I take a look at my x's, if I added them together, okay, right now, they would add to 8x. And if I added the y's together, negative 6y plus 6y, they will add to 0, so we would be eliminating them. So again, on this problem, we can go ahead and start the process of adding the two equations together, because we can already see that we will be eliminating the y's. Okay, 5x plus 3x is equal to 8x, and negative 32 plus 48 is the same as 48 minus 32, so that difference is 16. We need to divide each side by 8, and that leaves us with x equals 2. So we do have half of our solution. So as we write our solution, they usually don't do it, usually don't do this, but we do have half of it written down. And maybe if I go ahead and write that x is equal to 2, I won't do what I did on the last problem and substitute the 2 in for the wrong variable. Okay, so now I need to go back to one of the original two equations. Again, it does not matter which one I go back to, but because the second equation doesn't have any negatives, that's the one I'm going to work from. And I am going to replace x with what its value is, which is 2. I know that 3 times 2 is 6, so 6 plus 6y equals 48. And to solve for y, I need to subtract 6 from each side. That's going to give me 6y equals 42. When I divide each side by 6, that will leave me with y equals 7. So now I do have my solution of 2, 7. So the solution is the ordered pair 2, 7. Example 3. Y minus x equals 13 and 7y plus x equals 11. I know I told you that the variables, that the equations needed to be in standard form. And these two equations are not in standard form. I just want you to notice that it really doesn't matter if the x are before the y's, if the x's come first and the y's come second, as long as the variables are lined up and the constants are lined up. So when I said standard form, okay, it's okay if it's not in the form ax plus by equals c, as long as our y's are lined up, our x's are lined up, and our constants are lined up. Okay, as we prepare our variables, and if we added at this step, notice that y plus 7y would have a sum of 8y. Negative x plus x would have a sum of 0. So we are ready to start the elimination process because these equations are perfectly lined up. Y plus 7y is equal to 8y. X's are eliminated. 13 plus 11 is 24. So when we solve for y is equal to 3. Okay, so we have half of our solution. Okay, so our solution, we know that the y coordinate is equal to 3. So I need to make a choice and use either the first or the second variable, or first or second equation. Again, I think I'm going to use the second equation because it's all positives. 7y plus x equals 11 is my second equation here. All right. And I know that the y coordinate is 3. So 7 times 3 plus x equals 11. 7 times 3 is 21. 21 plus x equals 11. So to solve for x, I need to move a positive 21. So I'm going to subtract it, leaving me with x equals 11 minus 21, or negative 10. So my system is negative 10, 3. Okay, I haven't been checking all of the problems, but I think it's time that we do go ahead and check. So with the first equation, y minus x equals 13. Y minus x, okay, I know that y is 3, x is negative 10. Does that equal 13? Well, 3 minus a negative 10 is the same thing as 3 plus 10, so sure enough, that's equal to 13. Okay, the second equation was 7y plus x equals 11. I know that that's going to be true because, okay, that's the second equation that I used, the equation I used to solve for x, but I'm going to go ahead and check anyway. All right, so 7 times 3 plus negative 10 equals 11. That's going to be 21. 21 minus 10, does that equal 11? Sure enough, it does. Okay, again, now I feel really confident. I know with 100% certainty that my solution is correct. Okay. Let's get that one. Okay, here's our next system. negative 2x plus 15y equals negative 32. And 7x minus 5y equals 17. 7x minus 5y equals 17. So the first thing I'm going to do is line my equations up. And I'm going to look at what would happen if I just went ahead and added the two equations together as is. Well, the x's would not cancel out because their coefficients are not opposites. And as I take a look at the y's would also, okay, not be eliminated because their coefficients are also not equal. Okay, so this problem is going to require more work. Okay, that's good because we love more work. All right, so we're going to go ahead and take a look at what can we do. All right, as I take a look at negative 2x and positive 7x, okay, I would need to think about what would I have to multiply 2 by and 7 by so that they would have opposite coefficients. Okay, and I'm thinking I'd have to multiply the top equation by 7 and the second equation by 2. Okay, that's one option. Now I'm going to look at the y's. I have a 15 and a negative 5. And right away, I'm going to get a little more excited about this one because I can see that, well, if I could just multiply this 5 by a 3, then that coefficient would be negative 15y. And added to a positive 15y, that would allow me to eliminate the y's. The problem is algebra doesn't work that way. I can't just pick and choose which variables. I can't just pick and choose which variables I get to multiply by. So it is all or none. I multiply an entire equation, okay, by a value or none of the terms. So I'm going to go ahead and take this second equation and I'm going to multiply each and every variable, okay, each and every term by 3. So I'm using the multiplication property of equality, and what that allows me to do is multiply both sides of the equation by 3. I started with a balanced equation. It's going to remain a balanced equation. So my first equation I don't need to change. Negative 2x plus 15y equals negative 32. The second equation, because I'm multiplying each and every term by 3, both sides by 3, is going to be 21x minus 15y equals 17 times 3. What is it? I can do it. It's 51. Okay, so now when we add these two equations together, the x variables, okay, if we add the x's together, negative 2x plus 21x is 19x. The y's are eliminated. And negative 32 plus 51, well, isn't that convenient? That equals 19. And to solve for x, I will divide each side by 19. So I have half of my solution. X is equal to 1. So I know that my solution is 1, and then whatever I find for the y coordinate. Okay, it's really going to be helpful if I go back to one of the original two equations, either this equation or this equation. Both have negatives. All right, I think I'm going to go ahead and use the first equation, negative 2x plus 15y equals negative 32. It doesn't make any difference. I know that my x coordinate, or my x solution for x, the x value is 1. So negative 2 times 1 plus 15y equals negative 32. That leaves us with negative 2 plus 15y equals negative 32. To solve for y, I need to move this negative 2 to the other side, so I'm going to add 2 to each side of the equation. It's going to give me 15y. Oops. I did it again. Okay, thinking ahead. All right, there we go. So we have negative 32 plus 2, which is negative 30. And so we are going to get a nice answer here. And when we divide each side by 15, y is equal to negative 2. So my solution is 1, negative 2. Okay. Now, this last example, okay, was definitely more complex, required more steps. And that is kind of a lead into what we're going to be doing on day 2 of elimination. But I wanted to, just give you a little bit of preview for that. All right, have a great evening. Be ready for class tomorrow by making sure that your notes are done, that they are titled, because before you get to start your homework in class, the problems, you need to show me that you have your notes. Have a great evening.